Good evening, everyone. This is Fahim, and we are back with more data science demonstrations. With the start of a new school semester, we have more topics we need to cover before we finally finish the program. Today, we are going to be looking at data mining in SAS eMiner, some of the pros and cons, a couple of the applications, a demonstration in the actual program before wrapping things up. Some of the pros of SAS eMiner and data mining performed in it is that you will not need to perform any type of coding or SQL for this. The program has it integrated. All you need to do is connect the nodes, run the nodes, understand what the nodes are displaying to you, and you have your program. It's also very simple to perform ensemble modeling in it, which is exactly what we'll be exploring in this video. You are able to hook up multiple nodes to a final model that you are able to analyze that compares all of those nodes together, and you are able to draw conclusions from that by yourself. A couple of cons with the software that we'll be using is that it's expensive, it's closed source software. The only reason I have access to this is because I am a student. There's no advanced visualization techniques that you get from Power BI in Tableau. This is its own standoff thing where you are at the mercy of what tools they give you, which is just basic color changes and graph representations for your visualization. It's also hard to integrate other software with this. This is not like base SAS where you can integrate your code with Python to use databases inside of websites. You very much just have to use SAS eMiner for your data mining techniques. With that being said, there are some pretty serious applications with this. You can perform risk scoring and credit scoring with some of the tools inside the program, which are able to assess applicants on whether or not predictive modeling can determine if they will be good or bad customers for a specific company. It takes into factor a lot of probability along with business considerations such as typical approval rates, turnovers, losses, and a final decision can be made from those inferences. And you can even generate a couple of scorecards to determine different cutoff thresholds that a certain company may need to look at. You can also perform different decision tree processes, which is off to the right here, which is just providing a set of rules used to generate predictions for different sets of data. You can do different business generated decisions, and one of the applications is right here, which is if a certain court is determining how much money can be made from different defendants and plaintiffs, depending on whether or not a settlement is made, you can split 60% of the data going one way, which have a payout of $30,000, or the other 40% where a judgment is denied, and then that is split a further 50% and another 50% for the plaintiff and defendant, depending on how much money is made, where the most extreme values are down here, which are less likely to be encountered but still need to be considered in the overall picture. Here we have what our main program looks like. It looks very similar to base SAS, where you have different data sources and diagrams that you must create by dragging and dropping original data sources into the program. And then what the strengths are is you're going to be able to connect different nodes in order to make your final interactive comparison. Now, this is our original data set. I believe this one compares the different ages for veterans to a related gift card company. We have an overall metadata that we can split between whether or not we need to impute variables, which needs to be done for regression modeling. This will not need to be imputed for what we're going to be used for the decision trees, because decision trees do not need to have imputed variables. Decision trees are very robust, unlike regression modeling, so we do not need to replace unknown variables, which would be here, of course. But you need to perform a data partition, which splits the data different ways depending on your training and validation data sets, and then you can have different trees in order to find your ultimate comparison that you are trying to make. Your different decision trees have different parameters that are tacked to them, such as your target criterion, whether or not you are trying to perform different assessments. With your subtrees, you can perform an average square error method, which will determine your trees that have the least average square. You can perform just a basic default method, which is the decision method, which will determine your interval to target ratios, and then you're able to compare all those models all at once to determine which model is going to be the best one. I understand I am moving a bit fast with my explanations, but believe me when I say that if I were to go into every single node, describe what it does exactly, and then perform the entire run of the ensemble, we would be here all day. And that is not a joke. This takes a few hours to understand in depth in the actual applications of them, but at the very least, we can at least edit the variables here and understand what the actual data set is looking like in the variables. We need to have our target variables with their roles and levels marked as target. It's already labeled here what they're supposed to be, which was helpful from the dataset that we were provided. But then we have the different variables that need to be inputted in order to determine how the splitting criteria will be handled throughout the nodes. I believe I did do a replacement for just some of the missing variables, just in case I need to perform a regression model in the future. That's already handy, but that should already be where this is leading to in the future, depending on whether or not we do cover that in our course. Of course, the data partition is here to split the training and validation data sets, and then once you finally get down to your decision trees and are able to change the parameters depending on how you want them to be split, you are then able to run the entire model comparison and check the results. Thankfully, this was run beforehand because it does take a few minutes to run, especially on older systems, because of all the models it is attempting to create. But once this is loaded, we will take a look at the different comparisons that are able to be made from all the trees that we have made up until this point. And I still think it's trying to run it right here, so that's kind of funny, but we can hold tight for a second. And there we have it. Very, very cool stuff you're able to perform here. You're able to look at the ROCs and the different averages in square error to determine which model is the best for the different applications, whether you're trying to go for the lowest average square, which of course should belong to the lowest average squared model, depending on whether you want an interval to target ratio or depending on an ROC. Whatever you're trying to really aim for, you're able to do a model cutoff and compare it in this window right here. You are able to view different properties and model assessments such as statistic comparisons. Let's check what that does right here. And this will bring up all the different statistics such as fit statistics, validation sets. Now I think it resets when I run this. Yes, it did. I'm going to have to find it. Let's look for the average square error, the train. Let's drag it all the way to the front here, which is the least. Train 2 is the least, and that should be the average square error. So yes, you are able to perform those validations in this method right here. You have a lot of different tests you can take a look at, but this is just one of the great strengths. That took me a span of 5 minutes to demonstrate how to make nodes, how to link them up to one ultimate model comparison, and the program will run the rest. That is the ultimate strength of SAS eMiner. Performing data mining tasks in it, there is very little that can compete with the ensemble this is able to perform. And this doesn't even take into account a future video, which hopefully I will cover over credit scoring. Until then, I hope you guys were able to learn something new from this, and I hope to see you guys next time.